Hello friends, it's Mrs. Prickett and I am so excited about today's activity, and I love that I get to help your teacher out and help you guys learn a little bit more about force, motion, and work. So I know I've already done one fun activity with you, but let's go ahead and review just to make sure we're all on the same page. What is force? If I'm talking about force, what does that mean in science? Who remembers? That's right, it's either a push or a pull, right? Could be either one, but either of those are examples of forces. A push is a force and a pull is a force. So then, what is motion? Who remembers that one? Yeah, it's when something moves or changes positions, right? So motion is changing positions. Do we agree on that? Yeah? Okay. So then the last part, work. That's something that's kind of brand new this year, isn't it? The idea of work, not like homework or yard work or anything like that. Scientific work. What is that? You're right, it's another two-part definition. It has to have a force, so a push or a pull, that does what? That does motion, right? That changes an object's position. So there's got to be a change in position, otherwise there's no work happening, right? Like if I were to go push on the side of the wall, and is the wall gonna move? No. So even though I feel like I'm working really hard, there's no scientific work happening because although I'm applying a pushing force, that wall is not changing positions. So you have to have both. You have to have a force and you have to have something change positions, right? Okay, so that was just a little review of force and motion and work. Today we're going to be doing an activity similar to the last one I did with you, where we had the lever, right? And we had to lift the load, and we measured how much force it took to lift that load using paper clips. Now, do you think paper clips are a very precise and scientific form of measurement? No, I don't either. That's what we call a non-standard unit of measurement. Now, when you were like in kindergarten and first grade, you used non-standard units of measurement to measure how long things were. Like maybe you measured with popsicle sticks or paper clips or snap cubes to see how long things were. But now that you're third grade scientists, we use rulers and yardsticks and meter sticks to measure centimeters, right? And for mass, we use grams. Well, if we're measuring force, we use another brand new tool. Y'all are learning so many new things this year. We use a tool called a spring scale, okay? And you pull down on this little spring scale and see how it goes from 0 all the way down, okay? And there's two sides of the spring scale. One side measures with grams, which is for measuring weight, right? But we're not measuring weight, we're measuring force. So we're gonna be measuring with newtons, okay? So it goes from 0 newtons at the top. There's no force being applied on this spring scale. And then the numbers get bigger and bigger as you go down. You've got 0.5 and 1.0 and 1.5 all the way down to, can you see that one at the bottom? 5 newtons. 5 newtons, that's the greatest amount of force we can measure on this spring scale. Okay, so we are going to do an activity today. We're gonna lift another load, but this time the load is a bottle of green tea, okay? So first, we're gonna measure how much force is used just to lift the green tea without any sort of extra tool or anything like that. So I'm gonna put my spring scale on the string, okay? Woo! And I'm lifting that green tea bottle. You see that? I'm gonna bring this in close to the camera. Woo! Lean that in. Can we see where that's at? Ooh, it is past the 5. So 5 plus grams. We don't know exactly How many? Oh, not grams, newtons, sorry about that. More than 5 newtons is how much force it's taking to lift this bottle of green tea. So I'm gonna go ahead and write that down. I'm gonna use my mathematical symbol for greater than, right? Greater than 5 newtons was needed for me to lift that bottle of green tea because it went past the 5 on our spring scale. So we know that that's more than 5, okay? So now we're gonna do the same thing. We're gonna lift the bottle of green tea, but this time I'm going to be using a tool to help me. Last time when we were lifting that eraser, we used a lever. This is called a pulley, okay? It's a wheel, and that wheel's got a little groove that the string is gonna go through. And we're gonna see if using this pulley helps make the work easier or not, okay? Now, if you remember back to the lever lesson, we were able to prove that using or moving the fulcrum or that center piece of the lever closer to the load, we used less paper clips. And we said that less paper clips equals less force. And if you're using less force, then that means that the work is easier, right? So the same thing should apply here. If we're using less force, which is less newtons, then the work will be easier, okay? So if when I lift that tea bottle again, it's still more than 5, then the work was not easier, right? But if we get a number that's less than 5, then that means there's less newtons, which is less force, which means that the work is easier. So let's wait and see what happens, all right? I'm going to attach my green tea bottle to my pulley, okay? And then I'm going to lift. Woo, goodness, it's all twisted here. Lift on the string. Gotta make sure it's lined up on my pulley. I know you can't see it, but you'll be able to see it in a minute, okay? So now I've got my spring scale. I've got to reattach it to the other end of the string here so I can measure how much force it's going to take. So here's my spring scale, and I'm gonna lift, and I'm gonna have to stand up for this, guys. You ready? Standing up, backing up, so you can kind of see. I'm lifting, I'm lifting, I'm lifting, I'm still lifting, and I'm lifting, and I'm lifting, and here comes that bottle of green tea, right? Okay, so you can see that the pulley lifted it up. I'm gonna lower it back down a little bit, just enough so that we can take a look at how much force is on our spring scale. Okay, so do you see that? It's right here between the 2 and the 2.5. So that's about 2.3 newtons, right? It's a little bit more than the 2, but a little bit less than the 2.5. So we're gonna say about 2.3 newtons. So when I use that pulley, we got less newtons. Now what does that mean about the force? That's right, less newtons is like less force. And if we're using less force, then that means that the work is easier. Now remember, was it hard for me to lift up that bottle of green tea? No, it was not. But scientifically, it was harder just to lift the bottle by itself than it was using the pulley. The pulley helped make it easier because I had to use less force, less newtons, okay? So you have to remember, less force equals less work or easier work. More force equals harder work, okay? Keep that in your brains, and I know you guys are going to rock the test when you take it. Keep up the good work.